You're welcome to FUNNYMATH page. This is the 13th episode, of the BECE likely examination question. I wish you good luck in your exam. If you've been following me from, the episode 1 up to this point, I know you've learned a lot. Now let's answer this question or these questions here. Now, the first question is, the table shows the distribution of marks obtained by learners in an examination. And these are the marks. You see they are grouped. This is a group data. 21 to 30 as the first group, 31 to 40, 41 to 50, 51 to 60, 61 to 70. So these are the groups, and we have the respective frequencies here, and we are to draw a histogram to represent this distribution. And after that, we are going to use the histogram to estimate the mode, and then we find the median class. So this is what we're going to do for the first one. The next questions are also here. So now let's begin. But before we begin, you have to know this. We are representing this data, using histogram. And we have to make sure that, we have two ways to do that. We can get the class midpoints. We can also use the class boundaries. Yeah. So I'm going to use the class boundaries for that. But before we do that, you should know that this data should be continuous in such a way that the first group is 21 to 30. The second one is 31 to 40. This is not continuous because 21 to 30, the second one is supposed to be 30 to, let's say, 41 or let's say 40 or whatever. But it was not like that. So we have to redraw the table, the frequency distribution table, so that we look for the class boundaries, and that will make the groupings continuous. That's what we're going to do here. So let's get the tables right now. So this is how we can redraw the frequency distribution table. So this time we have the class boundaries here. So the first one we have 21 to 30. Let me get that one here. 21 to 30. The frequency is 15. And we have 31 to 40. We have 41 to 50. We have 51 to 60. And the last one is 61 to 70. So let me get the respective frequencies. That's going to be 20. We have 40. We have 30. And then we have 10. So these are the frequencies. Now let's move on to the class boundaries. Remember that we are doing the class boundaries because these groups are not continuous. From 21 to 30, it's supposed to be 21 to, let's say, 30. Then we come to, let's say, 30 to 40 in that order. But it's not like that. So there's a break between this point, the upper class limit of the first group and the lower class limit of the second group. It's supposed to be, the same. So the upper class limit of the first group should be the same as the lower class limit of the second group. That will make that continuous. So that's why we're going to find the class boundaries here. So let's get it right now. To find the class boundaries is very, very simple. We just have to subtract, 0.5 from the lower class limit. So that's going to be 21 minus 0.5. Then we add 0.5 to, the upper class limit. So we're going to do that, to all the groups here. So let me begin with the first one, which is going to be 21 minus 0.5. So it's going to be, 20.5. So we have 20.5 here. 2. So the next one is going to be 30 plus 0.5. So that's going to be 30.5. So that's it. So we're going to continue the same thing here. So now 31 minus 0.5. Always we subtract 0.5 from the lower class limit. So 31 minus 0.5. So that's going to be 30.5. So you have 30.5. 2. We add 0.5 to 40. So we get 40.5. So now you can see that the upper class limit of this one, of this first class, is the same as the lower class limit of the second, group or class. So that is what we are just, expecting. So let me continue with the next one. So we have 41 minus 0.5, and that's going to be, 40.5. 2, 50 plus 0.5, we have 50.5. So the trend continues like that. So here is going to be 50.5 to 60.5. You have seen the trend. So now let's move on to the last one. So that's going to be 60.5 to 70.5. So that's the last one. So now we have a continuous group. We can now represent this one on the histogram. So now let's move on. So you have to get your graph book ready because we're going to draw the graph for this data. So let's move on to the graph sheet. This is our graph sheet, and I've done this one already. We have the marks here. That's going to be for the horizontal axis or the S axis. So these are the marks. And then we have the frequency. That's going to be the vertical axis or the y-axis. So in this case, I've chosen this scale. Depending on the frequency that we had in the frequency distribution table. So you can see that if I'm to use this scale, this scale is going to help me a lot with the frequencies. So we have 5, 10, 15, 20, 25, 30, 35, 40. So always you have to choose, a suitable scale to be able to represent all the data on a graph. Now we come to this, X axis where the marks are. That's the most important part. So I told you initially that the midpoint can be used for this histogram, but we decided to use the class boundaries. So that is why we have these ones here. So when you go back to the class boundaries, you see that the lower class boundary was 0.5, and then the next one was 30.5 in that order. So that is what we have done here. So these are the class boundaries. Now let's begin. So you should know that when you consider the class boundaries, we have, let me get that one here. We have 20.5 to 30.5. So that is forming a group. We are going to use a rectangular bar to represent this group. That's what we're going to do here. So now let me do that one here right now. And the frequency for that was 15. So this is 15. Now it's going to be like this. So this is 20.5, and it forms a group with the 30.5. So it's going to be like this. So that is how we can get our first rectangular bar. I didn't use this portion. I didn't use that. We normally use a zigzag to to connect the lines here. We call it the squiggle or the zigzag break or the axis break, just to show that we are not starting from zero. We just keep some numbers. Now we are starting from 20.5. So you can also bring that one here, but if we don't bring it, no problem. So we are done with the first one. The frequency is 15. We come to the second one. The frequency is going to be 20. That is from 30.5 to 40.5. So you should know that for histograms, we don't leave any space between them. And this one, you can't even leave any space because this is a continuous graph or data, 0.5 to 30.5, and then 30.5 to 40.5. It's continuous, so you can't leave any space between them. So let's get 30.5 to 40.5. The frequency is 20. So with the help of your ruler, you can get all these. So I'm going to continue from this end. It's going to be like this. So this is 20. Continue from this end. Excellent. So I have to connect to the 40.5. That's going to be this. We have it like this. So you just press that down to the 40.5. The next frequency, that is 40. A very long one. So we are going straight to this point, and that is 40.5 to 50.5. So that's going to be here. I have a long way to go. So it's going to be this. Yeah, that's going to be this. Good. Oh, this is not straight. Let me get it straight here. So that's going to be this. This is very straight. So now we connect to 50.5. That's going to be this. Good. Now we connect to 50.5. We have a long one to go. So that's going to be here. Very good. That's very nice. And the next frequency, that is from 50.5 to 60.5 is 30. So this 30. So we have to begin from this end. So that's going to be here. Good. And we trace back, down to this point. Excellent. And the last frequency, that is 10. That is from 60.5 to 70.5. So this is 10. So we're going to trace from this end. Good. And now, good. So that is it. That's a very nice graph. That is it. Now let's move on to the next question. So if you track back to the next question, we have to find the mode of this distribution. So you know that the mode is the highest number or the highest frequency. But this time for histogram, we have a special way to get the exact mode. Because here we are dealing with classes. Without the histogram, you'll not be able to get the exact value of the mode. So we have a way to do that. So this is what we're going to do. You just have to locate the longest bar, which is this one, this rectangle. And we connect, the corners to the immediate rectangles like this, like what I've done here. And we connect this one to this one, something like this. Very good. Now, you see they've met here. That's the point of intersection. I'm going to trace that to the point on the x-axis and record the mark or the number that we get here. And that's going to be the mode or the modal mark. So let me use a red ink for that one. Just have to trace from here, from the point of intersection, something like this, straight down to the x-axis. So that's going to be here. Now, you then record the number here. So you're going to record the number here. So with the help of your graph, you can get that exact number. And the exact number is going to be 47.5. So the mode or the modal mark is equal to 47.5. So you can use your graph to confirm that. So that is it. Let's go back to our next page to talk about the median, how to find the median. You see, for the median, we cannot use the graph to get it. So you have to go back to the frequency distribution table to find the median. I hope you've understood how to get the histogram. Let's get the question 1A. That's this question. So you have 1A. And the question is find the median class. The middle class. So what are we going to do? So we have to use the formula. This is finding the median from a frequency distribution table. Now, before we can use the formula, we have to know the total frequency because that plays a pivotal role here. So let me get the total frequency. So we have 10 plus 30, we have 40 plus 40, 80 plus 28, 100 plus 15, 115. So the sigma f is going to be 115. So that's the total frequency. This frequency or this number is an odd number. So since we have an odd data, we are going to use this formula. The median is going to be, so the median is equal to half of sigma f plus 1, th item. So what do you mean by this one? So that's going to be half of sigma f is 115. So it's going to be 115 plus 1 th. This th is just trying to give it the position of the middle class. So the th item. So you're going to get half of 115 plus 1 is going to be 116 th. Half of 116, that's going to be what? So that will give me 58 or the 58th item. That is why we have this th there. So we're going to look for the 58th item from the frequency distribution table here. So now, to get the 58th item, we just begin with the first frequency here, which is 15. We add from the top, trying to get 58. So let's begin. 15 plus 20, that will give me 35, which is not, up to 58. We have to continue. So 35 plus 40, that will give me, 75. We didn't get 58 direct, but we know that 58 is also within 75. So that means that the median will lie on this number. I hope you understand what I'm talking about. Because we couldn't get this 58 direct, but rather we know that 58 is within the 75. So that will fall on this one. And this frequency corresponds to the class 41 to 50. So this means that the median class is 41 to 50. And that is why they said they want the median class. So the median class is 41 to 50. So that is how we can find the median class. Now let's get our next questions. Get the 1B here. That is question 1B. So 1B, I. And this is a preamble. Given the relation y equal to x minus b all over x plus b, we have to express b in terms of x and y. So expressing b in terms of x and y means we have to make b the subject. So the relation is y equal to x minus b all over x plus b. So we're going to make b the subject. So this is a relation involving fractions. So first of all, we have to do away with the fraction. And how do we do that? We have to get the LCM. And the LCM, so that's going to be x plus b. That's a binomial. So I'm going to multiply through by the LCM, which is x plus b. Or we can also do cross multiplication in this case. So I want to just use the LCM for this one. So that's going to be x plus b multiplying y equal to x plus b multiplying the whole of this, which is x minus b all over x plus b. So that is it. So at this point, we know that the whole of this can also cancel this one. So we are done with the fraction. So we are going to get this. We have x plus b multiplying y equal to, what we have here is x minus b, which we can expand to remove the bracket here. So y times x, we have xy plus b times y, that's going to be by, equal to x minus b. So at this point, what do? We want to make b the subject. So you have to make sure that we group all the b's on one side. Because we have one b here, another one here. So I just want to bring this one here, this b here, then I'll take xy to the side. So that's what I'm going to do here. So let's see. So that will give me, by plus b equal to x minus xy. I hope you're not confused because I've taken this negative sign to this side. And that's going to be positive, b. So now we have by plus b equal to x minus xy. Remember, we want to make b the subject, but the b's are still, 2. So what do to make it 1? We have to, factorize, and then you see we have by here, and we have b. That means we can factorize b out. So b out, and b goes into by, y times. B goes into, b1 equal to x minus xy. So at this point, we have only one b. So to make b the subject, we just have to divide the whole of this side by y plus 1, and the whole of this side too by the same thing, which is y plus 1. So easily this one can cancel this one. So you are left with b left. So b is equal to, x minus xy all over, we have y plus 1. So this is how we can, make b the subject of the relation. Now the next question. So let's get the next question here. That is question 1b II. And we have to find the value of b when y is equal to 3 and s equal to 10. So that is from the previous question. That is question 1b II. Now we just saw that b is equal to, that's the answer. We have x minus xy all over, y plus 1. So that's what we got for b. And we have to find the value of b if y is equal to 3 and x is equal to 10. So we have to find b. We can do the substitutions here direct, but if you don't mind, you can still factorize this x out to make the work easier. Here, where you see x, you just have to put 10 there. Where you see y, put 3 there. I just want to make the work easier for me. So I'm going to factorize the numerator. So that's going to be x out. We have 1 minus, y. So all over y plus 1. So when you make it like that, it makes the work easier for you. So let's do the substitutions. So that means b is equal to, x is, 10. So you have 10 here into bracket. 1 minus y is 3. We have 3 all over. We have y, which is 3 plus 1. So that's what we have. Now let's do the, simplification. So we take the bracket first. 1 minus 3 is going to be minus 2. So that's going to be 10 times negative 2 all over, 4. So 10 times negative 2, that's going to be negative 20 out of 4. So we can still simplify. So 4 here, 1, 4 goes into 25. So that means we're going to get, negative 5 as the final answer. So that's the value of b when y is equal to 3 and x equal to 10. We have negative 5. Let's get our last question. So let's get our last question. That's going to be question 1c. And this is the question. A cylindrical container of height 28 centimeters and diameter 18 centimeters is filled with water. The water is then poured into another container with a rectangular base of length 27 centimeters and width 11 centimeters. We have to calculate the depth of water in the container. Take pi to be 22 over 7. So that's an interesting question. So initially we have, a cylinder containing this, water. Now, this water is poured into a rectangular base, container, meaning a cuboid. So we have to find the depth of water. That means the height of water in the container. So first of all, this is what you're supposed to know. Okay, let me write down the parameters or the information given in the question down before we continue. So the height has been given to be 28. I'm using small letter h for the height, which is 28 centimeters. I also want to use small letter d for the diameter. That's going to be, 18 centimeters. Now, this is what you're supposed to know. First of all, we have to know the volume of water in a cylinder. That's very, very simple. You just have to get your formula, and the formula is volume of a cylinder is equal to, pi r squared h. That's the area of a circle or the circular base times the height of the, the cylinder. So you just have to know this formula, pi r squared h. So in this formula, we will need, the height and the radius. From this information, the radius was not given. Now the diameter was given, so we can just, use this diameter to get the radius. You know that diameter is equal to 2r. You know this one. So 2 radii will give you 1 diameter. So since the diameter is equal to 18, we are just going to get, 18 equal to 2r. So to get the radius, we just have to divide here by 2, here 2 by 2. So this implies that the radius is equal to, 2 here, 1, 2 goes into 18, 9. So we have 9 centimeters. So that is how we can find the radius from this diameter. Now everything is set to find the volume of this, cylindrical container. So now the volume of the cylinder is equal to V equal to pi r squared h, and our pi, as usual, that's going to be 22/7. So we have 22/7 here times. Now we know the radius to be 9. So that's going to be 9 squared, times h, and the h, that's going to be 28 centimeters. So that is it. We can simplify this one, this expression. 7 can go into 28, 4 times. So 7 here, 1, goes into this one 4 times. So let me continue from this end. So this implies that the volume is equal to, 22 times 9 squared, which is 81, times 4. So when you do the computation, you're going to get 7,128. So the unit is going to be centimeters cubed. Remember, we are finding the volume. So that's the volume of water in this cylindrical container. Now, interestingly, we poured all this, water into a rectangular tank. So now we have this water, this amount of water in this, rectangular tank. Now, the dimensions of this rectangular tank are 27 centimeters and the width are 11 centimeters. Knowing that the volume of a rectangular tank is equal to the length and the breadth. So in this case, we are using the width. So I want to use the width here. I don't want to use the breadth because it will create confusion. So the volume of this rectangular tank is going to be the length times the width times the height. Yeah. So this is what you're supposed to know. Now, we've poured all this water into this, rectangular tank. That means the volume is going to be this amount, that is 7,128. So we have 7,128 equal to the length of this rectangular base was given to be 27. So we have 27 here, times the width, which was also given as 11, with the exception of the height, and that is the same as the depth of water in a container. So if you're able to find the h, it means we know the depth of water in a container. So that is how we can set up our equation. So at this point, we just have to divide the whole of this end by 27 by 11. So that's going to be 27 times 11, here 2 by 27 times 11. So the whole of this one will cancel each other. We have 1, 1 here. So that will give me the height to be 7,128 all divided by, when you multiply 27 by 11, you're going to get 297. So when you do the division, you're going to get 24 centimeters. So you have to spend time to, divide this one. So we have 7,128 divided by 297, and that will give you 24 centimeters. So that's the depth of water in the container. So you have to write something down for the examiner. So therefore, the depth of water in the container is 24 centimeters. So that is it. Thank you for watching.